But let's go look to see because yours is a different lesson than the programming one student. So let me put this up on the screen. We'll go through it quickly. I don't think it'll take a real long time. But this week is the actual first program. Programming 2 starting quicker than programming 1 did. Let's see. Procedural programming is what it's called when you get on to Buzz. But last week we had the first lesson, Intro to Procedural Programming. I don't remember if you were here or you came into Programming 1 class, but if you haven't done 1.01, that was last week. This week we're looking at algorithms. Let me go to the grade screen. Yeah, we had the Let's Have Serial thing. If you haven't done that, that's still open. This was last week's, the Intro to Procedural Programming. But this week we're looking at 1.02 algorithms. So let's go take a look and see what that is involved with. We're kind of starting some programming this week. Algorithms with Python. So an algorithm, that's a fancy name for just the series of steps needed to solve a problem. So developing an algorithm forces you to think through what steps do I need to do. That'll help you think through how to develop a computer program. So once you've defined an algorithm, you can outline a program using pseudocode and finally translate that into code. In addition, you can also use classical algorithms to solve problems. Those are steps that have already been written to solve problems. So let's look at this little sample program they have here. It says supplies for the food bank, define main, and this is just a comment because of the little hashtag there. Comment, variable set to number of apples. So it says apples equal. So we got to put a number of apples. And then this says, this is a comment as well, an if statement used to calculate the number of apples. And if it's true, it prints, please order more apples. So what does this if statement do? It says, if apples are less than or equal to 20, print, please order more apples. So this is an algorithm. It says, let's see how many apples we have. And if we have 20 or less, we need to order more. So when we hit run, right now it says, uh-oh, no SRC for file line 6. It's saying line 6 is an error. But yeah, because we didn't tell it how many apples. It just says apples equal. So let's say we've got 35 apples. So we're going to say apples equals 35. So now when we run the program, it doesn't do anything because all this does is if the apples is less than 20 or equal to 20, it'll print that. But if it's more than 20, it doesn't do anything. So let's change this to like 14 apples. Okay, we've got 14 apples now. Apples equal 14. If we run that, now it printed out, please order more apples, because it got down to this statement. It said, if the apples is less than or equal to 20, print, please order more apples. All right, let's look at slide 2. There's three different pieces to this. Slide 2. Read the code, try to predict the output. Use the last comment to add the missing code. So it's telling me whether we're missing some code, but the comments should tell us what it should do. Supplies for the food bank. Define main. Hashtag. This part of the program defines the variable as user input. So num equals integer input. How many apples do you have in stock? So this time, every time you're in the program, it'll just ask you, how many apples you got? Then this says, this checks for the apple supply. And if it's true, it prints, please order more apples. So that's again where it checks to say, do we have less than 25 now? If the number that we enter is less than 25, it'll say, please order more apples. And this says, else, if false, if it's not less than 25, then print current supply accurate. So they put the else statement. We've got to add another print statement. We've got to indent over, print current supply adequate. So that should do it because it said if it's false, so it means this is an if, this is the else. So if it's true, it'll do this. Else, if it's not true, it does this. How many apples do you have in stock? Well, let's say we have 2. Please order more apples. Okay, that's what we should have done because if we have less than 25, it tells us to order more apples. Let's run it again. Let's say we got apples in. Now we have 52 because we just got 50 apples in. It says current supply adequate. Okay, so this is just a little algorithm that checks the number of apples. And if we don't have enough apples, if we have less than 25 apples, it says it's time to order more. But if we do have 25 or more, it says, okay, we've got enough. The current supply is adequate for our needs. All right, let's look at the third example they give us. Supplies for the food bank. Define main. Defines the variable asked for the number of chickens. Number equals integer input. How many chickens do you have in stock? Check for the supply level. If the order is less than 30, then print, please order more chickens. So we're missing the if statement there. We don't have that. What do we have down here? Else, if false, print current supply adequate. Oh, they misspelled supply there. They got 3 P's. Let's take out. We'll fix their spelling while we're here. It's a comment, so it wouldn't matter, but we could fix their spelling. All right, so it doesn't have the if statement. So we've got to write the if statement up here. If num is less than 30. Right, no, do I put a colon after a number statement, if statement? I think I do. If number is less than 30, because it says if the order is less than 30. So let's run that. Let's say we have 22 chickens. Please order more chickens. Good, because that's less than 30. It should have asked us to order more chickens. Now let's check a number that's not less than 30, like 30. 30 is not less than 30. Current supply adequate. So since it was not less than 30, it went down to the else and said, okay, we've got enough chickens. So this is the algorithm it's using, just to check, do you have this much? If not, print this. If you do, print that. All right. Ancient algorithms. You ever heard the joke, which came first, the algorithm or the computer? Okay, you probably heard that differently. Probably not. The concept of an algorithm is really old. I mean, like thousands of years old. Algorithms have been around a long time. The ancient Babylonians first used algorithms 4,000 years ago to solve problems. Now, they didn't do it on a computer, but they had algorithms. The most famous algorithm is Euclid's algorithm. It's pretty old, too, about 300 BC. Euclid did a lot of work in math and geometry. But it's still used today to find the greatest common divisor of two numbers. Like any good algorithm, all you need to do is just follow the steps. Here, let's take a peek at the ancient code here. This is Euclid's algorithm to find the greatest common divisor. So, input, 2 positive integers. So we would have 2 integers. Let's say 20 and 30, right? What we want to get is the greatest common divisor of 20 and 30. So if A is less than B, change them around, swap them back and forth. So if it was 30 and 20, turn around to where A is 20. So 20 and 30. Divide A by B and get the remainder. Well, 30 divided by 20 is 1 with a remainder of 10. If it's 0, report B is the greatest common denominator. It's not 0. The remainder is 10. Replace A by B and replace B by R. So now it would be 20 divided by the remainder 10. And 20 and 10 would be equal to 2 with the remainder of 0. So B is the greatest common denominator of 30 and 20. Yeah, 10 divides into 20 and 10 divides into 30. And there's not a bigger number that divides into both of them. So there you go. There's 2,300 years ago, Euclid developed this algorithm, these 3 steps, to be able to find the greatest common denominator. And very famous ancient algorithm. All right, page 2, simplifying algorithms with pseudocode. So 1 step forward, 2 steps back. Solving a problem is rarely a simple endeavor. It's fairly common to choose an idea, build it, test it, and then find out it didn't work like you thought it would. Working through this process is normal. It's how you develop an algorithm. The step-by-step instructions to solve a problem. That's what an algorithm is. So step 3 of the 4-part computational process discussed in this course. Here's a secret. Writing pseudocode is the best way to work through this step quickly, efficiently, in natural language. It's English. It's so effective even if professionals do it. So pseudocode is an outline of your code in English that you go through one line at a time. So important, always write pseudocode first. Why? Well, for starters, you think in English. You don't think in Python. You think in English. So it's easier to work through the logic of what kind of algorithm do I need to accomplish what this program is supposed to do. I can think through that in English easier than I can think through it in Python. So I can write it down in English, and then I can work on translating it into Python. It says, what will you do with all that extra time, since it's so much quicker? Let's drum up some volunteers for an upcoming beach cleanup using pseudocode. So let's look at the example below and keep the following pseudocode best practices in mind. So pseudocode should represent all the steps necessary to complete the algorithm. It should make sense to anyone, even those who don't know anything about programming. They should be able to read it because it's in English. It should follow similar formatting to actual code, including indenting if statements. So if it should be indented in Python, we should do that in our pseudocode, just to keep us remembering that. And it should include comments, which are a necessary part of writing great code. So let's look at some examples here. This is pseudocode in this left box, and this is actual Python code in the right box. So the first thing it says in our pseudocode is start our program. Okay, that's the define main over there. When we start our programs, let's define our main function. Ask if they would like to volunteer. That's what the pseudocode says. So in the code, we would put comment, ask if they'd like to volunteer, to let people know, hey, here's what this part of the program does. It asks if they'd like to volunteer. And then the Python code is answer equals input, want to volunteer, yes or no. Then our pseudocode says, if yes, inform them of the location and time. So if we click on that, that lines up with this. If yes or no, logical operators. This is just a comment again. So here's the Python code. If answer equals yes, or answer equals yes, because that way we don't know if they're going to capitalize the Y. So this checks if they didn't capitalize the Y, this checks if they did. So either way, if they type yes, we'll know they said yes. If that's true, then print, great, please meet us at the local park tonight at 8 o'clock. Just let them know. You want to volunteer? Great, meet us at the park, 8 o'clock tonight. And then the next pseudocode says, if no, write perhaps next time. So that's this part of code. Can I turn those back off? No. If answer equals no or answer equals no, again, we're checking to see if they capitalize the N or not. Print, okay, perhaps you can help out next time. And then the end is just this line of code down here, main. It says, okay, I'm done, run the code. That's what it says. I'm done, go ahead and run the main function. So it told us down at the bottom too, if statement. So this is the pseudocode, and this is the code that matches it. This is a lot easier to think about. What I need to do? Well, when we start the program, I should ask if someone wants to volunteer. If they do want to volunteer, I tell them when and where to show up. If they don't, say, that's okay, thanks, get you next time. Yeah, that's all I need. And that's a lot easier to think for than answer equals input. Then I need an if statement, and if they say yes or yes, it's easy to write this first, and then we can turn this into code. All right, let's look at page 3. The end is just the beginning, the post-mortem review. We did this all last year in programming. Once you've used an algorithm and pseudocode to develop your program, you might think you're finished. Not so fast. Now comes the post-mortem review. That's a process to determine what was successful and what was not successful in a project to help you improve it next time. It's the fourth and final step in computational thinking. So a PMR, post-mortem review, is an essential tool that great programmers use not only to reflect on what they did, but to improve and upgrade it. After all, in the real world, you don't just create a program, hand it over to your boss, and never think about it again. You'd be expected to make it better, to improve it, provide ideas for future updates. But don't take it from us. Let's hear why programmers in the industry swear by doing a post-mortem review. Here's Emily Kay. She said, post-mortem reviews are great for telling others why you were right. If I came up with a brilliant solution, I want to brag about it, document it, and share it with my team. Here's what this program does. Here's why it works so great. Here's another one. Justin B. says, before I consistently went through the post-mortem review process, I made lots of silly mistakes. So taking a moment to stop and think through my programs helped me see where I was going wrong again and again and again. Every time when I look at the end, it's like, I keep making this mistake. I keep making the mistake. And that post-mortem review helped them realize that. Here's a Priyash P. I've had some of my best ideas for future programs by doing a PMR. That pause to stop, think, and reflect gives you a chance to catch your breath and then have a breakthrough. Oh, I could do this in a program. That'd be so much better. So conducting that post-mortem review. In this course, you'll be expected to complete a PMR anytime you turn in a program. So we included a sample below. So let's look at this one. Post-mortem review. What was the purpose of your program? The purpose of my program was to help the blood bank track its donations by type. It will print a warning when the inventory of a certain blood type dips below 5 pints. Okay, we got 8 pints of A positive. We got 6 pints of A negative, whatever. How could your program be useful in the real world? This program could help blood banks identify critically low blood types. Maybe we've only got 2 pints of this left. What is the problem you ran into? How'd you fix it? I was having difficulty developing the algorithm that would identify if inventory was running low. I decided to go back and think through the algorithm again in pseudocode, which helped me better understand the actions I needed to take in my program. What's one thing you do differently next time? Next time I'll spend more time planning my program through the pseudocode and I won't have as many errors while coding the program. How could your program be generalized and useful in other areas? This program could be adapted to any business or charity that needs to track inventory levels, whatever they're tracking. Perhaps a food bank could use it to track donations and low supply levels, or a gift drive could use it to track specific gifts that may run out quickly. All right, page 4. Programming with the Python idle tool. In this course, you have access to the Python idle tools. Right up here, click the idle button. There's where we write our programs. It's all right here. There it is. There's where we write our code, right there. This tool lets you do about everything. Write, run, debug programs written in Python. The idle in your Python programming environment for this course, it says an easy way for you to practice programming while you work. The idle checks everything you type with punctuation, typos, keywords. And when you get an error message in idle, don't worry. Making mistakes is a key part of programming. Important, this course has a built-in idle that runs a version of Python 3. So this has its own specific Python version. It is possible that any code you find outside this course, you may go to other websites where you can write Python code somewhere else, and it may work there, but it won't work here because we have a different version of Python. So before you turn anything in, make sure it will run correctly in our Python idle. So using the in-course idle. This video below will show you how to run, write, and save programs. Yes, because we have this save option that's really nice and working for us now. They've made some changes from last year's idle to this year's idle. So let me play this little video. I've saved this video because I think it's really useful. I'm probably going to put it in. Oops, that's not the window I want. I'm going to put it in our Google Classroom as well to keep this little video because I think it's very useful.
Let's talk about how to write, run, and save Python programs with the built-in idle. You can access it anytime in the course toolbar. To start, use hash marks to add comments to the header, including your name, date, and the program's purpose. Now let's try writing some code. Starting on a blank line, define the main statement. This Python function tells your program where to begin. Now let's use Python's print function to display the string "Welcome to Python." Be sure to indent this line with 4 spaces or Python won't recognize it as a command. Finally, call the main function to run the code located in the main statement. When you select the Run Program button, the program will output and print "Welcome to Python." Now let's get some information by using the input statement. Under the first print statement, type the variable first name, then the equal sign, and then an input statement asking for the user's name. Now let's use this variable. On the next line, type a print statement that says, "Get ready to change the world." Then a plus sign, and the variable first name. When you select the Run Program button, the program will ask for the user's name. Once entered, the program will store that data in the variable first name, and then use it to print the string with the user's name. When you're finished, select the Save button to save your program to your computer's hard drive. To double check your work, select the Choose a File button. Then, select your saved work. Notice that your program was saved as a compressed file. Select it and the in-course idle will open your program.
So you'll have to figure out where your Chromebook saves that on your Google Drive. I mean, it'll save that file. But yes, you can turn in programs using the save button and turning in that zip file. So you can save your programs in that zip file wherever your Google Drive stores that. You might want to create a folder and keep them all in one place. And then you can just reload it. You can choose a file and reload it and pull it right back in. You don't have to start over if you lose it. I know sometimes we have those issues where, I closed it and I lost my program. Save those things from time to time. Save it. If you're writing a long program, save it in the middle. Don't wait till the very end to do that. But that is how you can turn programs in now, is with the little save file, because that's working really well. So Penelope has a lovely little sample for us there. Or I guess you could call her Penelope if you want, right? If you don't, no, I'm sure it's Penelope. All right, that is the end of the lesson. We've got the assignment. I'm going to go here and buzz the show. Submit the template and the save program file. So I'm going to just let you attach the file and the template, but I want to look at the template I've got here in Google Classroom for us. If we go to classwork, algorithms template. Use pseudocode to design a program that simulates a conversation with an online representative. For example, this could be UNICEF, which is the United Nations organization that promotes the rights and well-being of children around the world. It's a big charity. Because it's so important to always begin coding using pseudocode, the pseudocode has been provided for the first program. So you don't have to write the pseudocode this week. Here it is. Here is the pseudocode for this. So take a look at it now, along with the expected output, to understand what your program will be doing. So start, and then they indent that because everything inside your main function would be indented. Ask what their name is. So figure out who's using the program. Say hi using their name. Tell them something you know about computational thinking or a great programming idea to change the world. And say bye using their name and end. So, okay. So here's an example of some expected output. So it could be, hi, Sammy. And hi, Sammy could be on the same line. They got it on two different lines for whatever reason. Computational thinking can be used to algorithmically solve problems. Bye, Sammy. So there you go. They did something they knew about computational thinking. You can also do something about a great programming idea. Let's see. Did I? No, I didn't save that over there. I have a program I saved. I wrote a little program to simulate that, but I got to find where I put that. All right, so that's part one. Here's the pseudocode, and here's what it should look like. So translate the provided pseudocode to Python. Use the Python idle built in the course to code and run your program. So your code must run successfully, produce the output above. Right? If you got any errors, get with me. Follow the Python style convention regarding indentation, use a white space, all that good stuff. Use comments to include your name, date, and short description. All programs, we need to make sure we've got all these comments at the top. There's name, date, and what program is this. Part two, the post-mortem review we talked about. Purpose of program, how it can be useful, good stuff. So this one's pretty useful, pretty simple in the fact that they already gave us the pseudocode. So that really shortens this. First one's going to be a lot shorter, easier to do, because we don't have to do any thinking. We just have to follow the pseudocode and write the program that goes with it. So this will make a copy when you click on this algorithm template. It should make a copy for you. And then you can just submit both the files. You can submit the program file and the template file right here. So that's it. Our first program. Yay, jumping in there. Yeah. I'm excited about this course. I think we're gonna learn some cool stuff about programming, and we're gonna become better at our programming skills. And I like this. Make sure we include our comments throughout the program to just kind of help it easier to read for other programmers. And we're going we're going to look at later on. I've just browsed a few months ahead. There's going to be some points where we're going to look at other people's pseudocode and say, could you write the program? See, that's a good test of it. If you take someone else's pseudocode, could you write the program and make it work based on their pseudocode? So think about that when you're writing your pseudocode. If I just wrote the pseudocode and I wasn't writing the program, I need the pseudocode to explain enough to where somebody, I can just hand this. Okay, I just write pseudocode here. You go write the program. I got to work on the next program. That's what you want to think about with pseudocode. Could somebody take your pseudocode and write it? So this is a good practice for that right here, because we're taking someone else's pseudocode right here and writing the program. So if it's not good pseudocode, our programs are going to struggle. They're not going to accomplish what they want to because they're missing steps or whatever. So that's why I like this one starting out, looking at someone else's pseudocode that's been written, translating to the program as a great buffer, a great primer for us to start doing that ourselves a little later. So. All right, guys. Well, you got a few minutes extra there before you got to get up to your orchestra class. So I'll go ahead and wrap it up for today. And if you guys need any help with anything, we have class. Let's see, this is an A-Day. It's an A-Day Friday. Again, we have 2 in a row since it's a short week. So we will have class again on Friday morning if you need any help with anything. So otherwise, have a great week. We'll see you next time.
What? Just ride. I just need a ride. I just wanted a little ride. That's all I needed. Come on, Big D. Come on. What is it? What?
Painting.
I just wanted to go to the wedding. That's all I wanted to do.